Assalamu alaikum, beautiful people. Hi everyone, welcome back. So before we go ahead, let's discuss what we have done in the last video. It was extracting the main information like summary and description from online blogs where we feed the list of different links into the feed parser and extract the information, and we try to create a data set, and we have done already and saved the data set into the text file. So we text file. So now we will do hierarchical clustering. Why we will do hierarchical clustering? Because the data set that we have extracted from online sources are unlabeled, is class variable is undefined, and we are also not sure how many classes we have possibility to create in this data set. So I will show you the data set, and if you're not sure how to create this data set by using feed parser from online links, you can go back into the previous video. And sometime hierarchical clustering, and why we need hierarchical clustering, it was whatever I said this before is about clustering when the class label is not defined. So using hierarchical clustering, every node of information, are, you can see here that this is the different nodes, or this, you can say that this is the raw 1 2 3 4 5, and on the basis of some feature it have own data, it also have data, and data. So we consider them all of points initially as a separate cluster. Then we try to find some similarity on the basis of some equation. We try to find the distance between them using some equation. It could be Manhattan, Euclidean distance, and another equation can be used. So if you look at this data, you can see that these visually you can see these 2 points are more closely related as compared to this one. So they are clustered under the same node, and same is the case for here. So this is confusing. They already calculated the distance between that and that, so it was more closer to this one. So that is why it is connected to this point. So another question: how we decide to have this much that number of classes? So it is very easily. We take help of Dendrogram. Dendrogram help us to how many classes would be used in clustering. So if you're not sure how many classes I have, you have to take help of Dendrogram. It helps you out how many class possibility you have. So you can see visually here very easily that there are most of them. There are 2 classes, that is that color and red color. So this is why you can say there are 2 classes here. So another thing that we just particularly in the other way there to find out how many classes. Usually people used to draw line on these lines, okay, and how many line it is crossing, that is 2 lines. So you can just put the line here horizontally, and how many line it is crossing, it is 3 line. And another is this is on the first number. You can say that you have 2 cluster, and if you want to create a 3 cluster, if you want to judge what is after 2 cluster, 4 cluster directly or 3 cluster directly, I have to put. So you can judge from here. This is the most longest straight line moving to the upward that is not interrupt until this distance. You can, if you want to go through this distance, it is interrupted all the way. If you want to go on this line, it is also interrupted all the way. So this is the second longest line after top that you can use to create a cluster. So 1 2 3. So you will see how 3 clusters are created. Easy peasy clustering. So what we will do today. So we will do today some important approaches here. So we will discuss dataset, and we have created dataset last time in txt format. We convert the same dataset into CSV format. So we create a dendrogram for our dataset using Scipy, and we will apply a clustering using Sklearn. And another that will be manually done is creating clustering for our dataset, and we will create a dendrogram and apply clustering to it. So that's it to the theory portion. Let's jump into the code. So here is the code portion. So data, you can, okay, let's just data equal to PD, okay, read CS V and CS V. PD is not defined. Okay. Alright, so let me show you our data set before we go ahead. So that is the data set you can see here. It is in CSV format and it is text format. So last time we have created this data set. Okay, so you can see what we have done without set. We remove this and also name of block, every blocks. First thing we have done to this, and replace this with comma, and also replace the tab space with comma. You can see here easily. It is here. You can see that. All right. Okay, so now let's play with the CSV. Okay, so now we have to check how many rows and column we have. Okay, so data dot shape. Okay, 99 rows, it means 99 nodes we have. So let's sometime we have, and you can see in data set we have sorry. Then so to overcome this problem, this data dot fill na 0. Why not we fill this? Okay, fill na 0. Okay, now see what happened with our data. Okay, you can see you have 0 0 0 0 0. Okay, now remove this so it can be clearly seen. Now what we will do now is to visualize this data set in using Dendrogram. Okay, import Scipy, cluster, hierarchy is Scipy cluster hierarchy. Okay, so plt dot we have already mentioned it already here. Figure. Okay, figure and fig size. So we will give fig size 20 to 20. So plt dot, let's title it blocks dendrogram. So p den equal to shc dendrogram shc linkage data method what. Okay, so you have seen it clearly how it is having it is telling us how many cluster you could possibly have. You can either use two classes, or you can either use 3 of them. So I will just do, for make it easy, I will go for 3 classes. Okay, now as you decided from visually how many classes you have, now it is easy to put here from data from Dendrogram, decided from Dendrogram that how many classes would you have in applying Sklearn agglomerated clustering. Okay, which is up down approach. So from down up approach, Sklearn dot cluster. Okay, import agglomerative. Come on. Merrative clustering is AC. Right, clustering is AC. Alright, this is okay. Sklearn cluster, import aglo is coming. Oh, yeah. AC equal to AC. How many number of cluster do you need? It will be 3. Okay, and my computer is a little bit dull. Come on, affinity equal to suggestion space, text space is not working. I don't know why. Euclidean. All right. Okay, linkage equal to what? So YAC equal to, we just create a variable and have all these 1 to 0. It will have all the data that is classified. It will have just label 0 1 2 like this. Okay, you will see how it is classified. Fit, it is not working still. Predict data. Let's see, is it working? No, it is not working. AC is not defined. This is agglomerative clustering. I hope it is. Number of cluster, I think it is need. That is why we need some type tests make problem. Okay, why AC? You can see our data is between 0, 1 and 2. So if you want to see what type of which number of rows data are in 0, you can see how many rows it have. Let's just data y AC equal to 0. You can see here. So how many rows affected? 28 rows. So obviously this is 28 rows. This portion, it is talking about this. Let's do 1. Okay, this is talking about this one. All right, so let's do 2, and this is talking about the most longest one, I think so. In it will we have about 66 hundreds. So you can just simply say that length data, okay, y AC equal to 0. All right, copy it and again 1 and again 2. Let's see, you can see here 28, 5 and 66. This is 66 rows, this is 28. You can see here this is 28 rows and these are 5 rows. All right, okay. Now it is time to do the same thing using manually. So we will do what? Grouping the blocks, because the data set is about blocks. But this time we will not use CSV. Maybe later on we will use CSV for manually. We will just prefer to go for TXT format. All right, grouping blocks using hierarchical clustering. All right, this is clustering, hierarchical clustering. All right, so you can see here in our data set that is in TXT format, we have to extract all this information and keep it separately, okay, and all the name of blocks separately. All right, and all the data of all blocks will be kept separately, sorry. Okay, now read the data from file. So diff read file and file name. All right, so reading, now we have to read all the file. Okay, that is lines equal to line for line in open file name. All right, let's send the data. Read file, what is the name of blog data txt. Is it working? Yes, it is working. Come on. Okay, I didn't print this. Print, no, do not print it. Print len lines. Okay, this is 100 blocks. We have 100 blocks from 0 line to, because first row is a column for names of columns. So we have 100 lines in our blocks. All right, okay. Now what we have to do, so we need column names, okay, that is line equal to 0 dot. All right, so before we add the column names, let's print line equal to 0 dot 0. Which one is this? Is the all, you can see there, this is all row column names. Okay, now let's split it, okay, by double digit. All right, we have split it out. So let's extract this out, ignore this one. So if you want to ignore this one, just 1 dot. All right, so let's put this in the column names, okay. We have column names successfully inserted. Okay, now we need row names and data separately, as I have discussed. For line in lines, okay, lines, and ignore the first column and do show all the rest of it. It means that. So print, let's see what is how to do. So let's print dot split, okay, /t, because every data number have table space in it, avoiding the name of block. We have to avoid the name of block. Okay, all right, this is awesome. Need to do something to correct it. Line is not defined. Okay, so you see, if I don't put here -1, you can see it will have name. So that is why I put name here. So it is p. Okay, I will show you how to put this in the data. So now each row have its own name. It need to extract it here. Okay, row names dot append, okay, line dot split, all right, /t and 0. Let's see is it working or not. For now, print. This is all the name of block that we are going to extract. So let's do it extract by making it onto. Okay, you can see here all the blocks names. All right, so let's append these block names to its file, to its rows name. You can say it. Or you just do undo by. Okay, rows name. Now it need appending data to data. Yes. So print line dot split line dot p. You can see here we have already did this. Does it have all the data? Right. Okay, it has all the data. So put data dot append float x for x in p. All right, it is appended. And repeat again until is death. Return return blog name, return words, blog name and data. Let's do this. Words, blogs and data. Now it is kind of error here. Must be some error. I know. Words is not defined, but you do not need to mention here words. And row name and data. Okay, so words, these are the words. You can see is it blogs, these are the blogs, and this and this is the data. Come on. All right, don't okay, now we have to decide if we inside a cluster, you know that if inside a cluster, if we are finding the distance between the 2 points, you have to use an equation. Okay, so I will show you which equation I'm going to use. Okay, let's deciding different distance equation. Sorry. Okay, from IPython dot display import image. Okay, image file name e/tutorial/picture. I remember it, picture/person. So let's go to the e tutorial picture. I don't remember this. This one. Which one is this? Okay, I just copied full link from there. So this is the equation we will going Pearson correlation coefficient will be used for finding the distance between two node in in the cluster. So sorry. So let's do this. From math import sqrt diff distance will be found from v1, that is v node 1, and v2 node 2, you can say. Okay, simple we will do simple summation first of all. Okay, simple summation. Okay, sum 1 equal to sum v1. Okay, now sum 2 equal to sum v2. Okay, this is done. Now sum of these squares. Okay, we have to do sum of these squares. Sum 1 is equal to sum equal to, all right, sum power v into for v in v1. Okay, let's copy and paste it. That is v2 and 2. Okay. Sum of squares is already done. Sum of square of that you can see here. Now we have to calculate the Pearson by doing numerator part. Okay, numerator equal to, okay, p sum minus, all right, p sum minus, where is the p sum? We didn't take the p. First we have to do p sum, that is product of sum. Okay, all right, that is sum of the product. Okay, now p sum equal to sum, and we have to just do this summation. Okay, so for doing this summation, so v1, all right, is I cross v small, v1 I cross v2 I for in I in range length v1, because both of the length are same. Okay, now is the numerator part. We will play with the whole upper portion. Okay, so doing p sum minus sum 1 cross sum 2, because already we have did summation. Okay, of both of these. Sum 2 by length v1. Okay, now denominator equal to sqrt, that is sqrt sum 1 sq square. This one we will have to do this one, sum of 1 square minus, we have to take power and bind n, power sum 1, okay, of 2 by len v1. Okay, again we will do sum 2 sq square root minus power sum 2 by 2, right, len v1. Any mistake I am facing? Maybe there is some mistake. All right, this is closed here, and yes, this is all right. It is working. Now if denominator equal to 0 0, return 0, else return 1 minus 0 minus numerator by denominator. So why we put 1 here? Because the item are if exactly matched, so it means that they will have exactly 0 difference. So to make some distance between the one, if they match exactly 1, if they match, they will be exactly 1. If they not match, they'll be exactly 0. So to make some distance of the similarity, if they are approaching 1 or approaching 0, so it will make some distance between them to keep not exactly on the same line, so that we can visualize it easily. That is why it is put here. So done. Now we will do hierarchical clustering. Okay, let's do pseudo code for hierarchical clustering. All right, let's make it a little bit bigger. One, initialize. First steps, initialize all column is cluster. All right, this is not the way. All rows are columns. Let's see, we will see rows are column. Not sure for now. Cluster. Okay. Number 2, find the smallest distance between two cluster. Okay, so what if we find the distance? So keep record of every 2 pair cluster. So what does it mean? That if you have 2 cluster and finding the distance between them, and if you already have record of these 2 pair of cluster, we do not need to recalculate again to find the similarity or distance between them. So we have to keep record of every 2 pair, so that to save our time. So pair then merge 2. Oh my god. Okay, close cluster. Number 5, create new cluster by down up approach. Number 6, delete the old closest cluster pair for next iteration. You can see here. So okay, now let's create class for it. You can see class by cluster. This is the class name. Let's define the constructor. Init self wake left. So every node in the hierarchical tree will have the following information vec, that is the list of data. Left point to the left side, and right point to the right side. Distance, how much distance it is near or away. So id equal to, for by default, equal to none. Self left equal to left, self right equal to right, self id equal to self vec equal to vec, self distance equal to distance. Okay, now this next function is the main function of this class, where we will create up down up approach. Sorry, just a second. So down up approach for so diff h cluster row, it will receive all the columns list data, all the columns of all the row of data. So this one thing more. So before we go ahead, every 2 pair of inside this function, we will compare every 2 pair of okay, let's talk about this later. So for in the beginning we will create every row as individual. Create every row is cluster. Okay, cluster equal to, okay, by cluster, that is the constructor, rows and I. okay, and id equal to I for I in range. So len rows, okay, that is so in the beginning we create every row in every row as a separate cluster, because it represents separately individually separate block. Okay, now we have to loop through every pair. Okay, right, so looping through every pair. Okay, let's do. Okay, now looping through every what we say looping through all cluster. So while len equal to cluster length equal to greater than 1. So what does it mean? It means that if because every time as we find any two pair closer to each other and find their index, we will delete in at the last of the loop, because on the next iteration we don't want our loop to find the same, to calculate the same two pair of node as the lowest pair. Okay, so by default lowest pair equal to 0, lowest pair equal to 0 1. So beginningly we just give 0 and 1 as a lowest pair for default, so in the beginning, so that it can be compared. So how will it compare, we will see in the next few steps. Okay, so closest, okay, distance. So as we have cleared it that by default we have created 2 0 1 indices cluster as the lowest, and we also declare declare as a default the 0 and 1 cluster as a closest. Okay, so we will compare inside the loop. If we have find more closer to having more closer nodes having having more less distance between them, so we will replace it later. Okay, so loop through every pair of nodes. Okay, now for I in range, okay, len cluster. Okay, len cluster. So what does it mean? It means that for every node, so for every node first cluster. Okay, if every time, it means that we will take one node and compare one cluster, we compare with all the, compare with second, compare with third, fourth, and so on. All right, so for j in range, okay, let's just clear this, because we are putting this I plus 1 because we don't want to compare himself cluster to himself. That will be creating ambiguity, so that is why I create the range. Okay, len cluster, that is for rest of clusters. Okay, now if the distances are if we are looking for checking the distances if already existed and notice, so we will just clear here that distances is equal to what? It will be dictionary. Okay, it is a dictionary. And one thing more is we want every new merge cluster that is created in our program will be pointed negatively, will be have id negative. Okay, so it will be identify. So current cluster id equal to 1 minus 1. So one thing more is notice too that if you notice the cluster having minus id will mean that it have more branch, and the cluster having positive id is mean that it doesn't have no branch. Okay, so if cluster I dot id and cluster j dot id not in, okay, not in distances. All right, distances. So what will they do if we have not already recorded this two pair of indexes of cluster? Then what we'll have to do, distances. Okay, okay, cluster dot I dot, okay, I dot id class dot j dot id will be sent to calculate the distance between them, so that it can be stored here. And after when a cluster return the distance, it will be compared with the t. Either we go inside this if function or not, we will retrieve the distances on the basis of record from distances key dictionary. Okay. here it is the point. So d equal to distances is, as I said this before. Okay, so class dot I dot id and class dot j dot id. All right, I hope it doesn't have any error. D is less than closest, then closest equal to d, and lowest pair equal to I and j. So this full iteration is for finding the lowest pair. Okay, this loop use for finding the lowest distance pair of node or cluster. Okay, now what we have to do now, it is the time. Once we have find out the lowest pair of cluster, we will find, now we will have to merge them. So merge vect, okay, so that we can create a new cluster. Class dot lowest pair 0. Okay, it will retrieve the 0 one and vect I on the basis of loop. Okay, and plus clust and lowest pair and 1 dot vec on basis of I. And this time we have to compare. There is some mistake here. Okay, cluster, I think there is 2, that is it. And also yeah, this is single. Yeah, it is. So class lowest pair dot vec I by 2 point, we are taking the average. Okay, for in I in range len class dot 0 dot vec. Okay, now we will create a new cluster, that are the merging of cluster. Now we will create a new cluster. Okay, so new cluster by cluster and merge vect left equal to cluster lowest pair of 0. Okay, and right equal to cluster lowest pair of 1. Okay, and distance equal to closest and id equal to current id. All right, okay, got it. Hope you have cleared your mind with this. Okay, cluster id, so it will create cluster id with negative sign. So what is next now? So now current id minus equal to 1 and del lowest pair equal to 1 del cluster lowest pair equal to 0, and append the cluster, append to what? New cluster will be appended. Now we have to do one thing more to return the topmost index, what call it, topmost index of cluster. So how gonna we do this is by return cluster equal to 0, right? So let's check it out how it work. Okay, how we will check it out? By doing copy paste here. So let's see this and how does it work. All right, okay, let's output this. Either is it returning the topmost node or not. Okay, one more important thing, it will working. Okay, it is working. So one more important thing here is current ID, cluster ID is negative sign because it is the sign that it is created from new cluster by merging two cluster. And one more thing here, it is we have deleted all those cluster which is already decided to be the most closest inside the loop, so that next time it cannot be considered the most inside the loop. So now it is a time to we want to print out which cluster are considered in under the same group. Okay, so we will create a dendrogram, but before dendrogram it is also important to see this how we can see this data in using simple print function. Okay, so let's do it. All right, let's do it. So diff print cluster. Okay, so it will just receive the cluster, and labels mean that name of block. Okay, none for now, default is set to 0. Okay, none, and number of cluster is 0 for now. It will be more clear if we it is the length. Number is for depth, how much depth we are going inside the loop, inside the tree. Now for I in range, okay, n and print, we will just create spaces for how many number of n's. Okay, this is used for. So if clust.id is less than 0, if it is negative, mean that newly created, it have branches. So negative mean negative id means that this is branch. Okay, not a basic node, root node. So print, okay, we have to print this thing. Okay, and consider with else if else positive id means that this is an end point. Okay, this is the end point. Okay, so if labels equal to none, okay, if label is none, so print clust.id int equal to, so what does it mean? So it means that if label there is no label, okay, then id have to be printed. Else if it have label, so print labels and clust.id. okay, so it will be print label under the id. Okay, now print the right and left branch by recursively calling this. If go upside please, if clust.right equal to no, dot left not equal to none, okay, print clust. All right, print clust. So clust dot left, recursively calling this so that it can print the information we have set it for. We have to can set the condition for label equal to n equal to, it is going into depth n plus 1. If clust dot right not equal to none, okay, then it means that print clust dot right labels equal to labels n equal to n plus 1. So let's print it out. Maybe we have some issue, but don't mind, we will solve it. Okay, so by cluster print, okay, what we will send to this function, we will send to this function clust right n block names. Let's see. Oh my god, no, it should not be this. We have to try this next time here. Okay, let's see what kind of error we face here. So if error is so much confusing, I will stop the video for a moment, and when I fix it, because it is wasting the time, when I fix it, I will back. I do this routinely, I do this every time, because it is confusing sometimes. If so small error take too much time sometimes. So let's do it. Okay, so a by cluster has no attribute print. Wow, what the heck is this? Print. It is not that mean. Print clust. Okay, print clust is not defined. Wow, it is defined, but you are not sure how to define it. Let's see it. So I'm going to stop it for now and fix it. I'll be back right now. अगर मैं इसके साथ पाई क्लस्टर लगा देता हूँ, okay, this is the result you can see. So, and you see this data, there are somehow they are looking somewhere in space, or they are grouped together. So this is because they are clustered under the same group, but this is not that much visible. Well, Dendrogram will help us to easily identify how they are clustered together, as we have seen in the previous videos. So we will create the dendrogram exactly like this in the next steps, but manually we have used in this case cluster Scipy library for hierarchical clustering. But this time let's do this by creating it manually.